Welcome to today's webinar, Migrating Applications to SDN Fabrics in Brownfield Data Centers. My name is Sharon Fitzpatrick, and I'll be your host for today's webinar. Joining me from the Big Switch team is JP Shukla, Director of Product Management, Ganapati Bhatt, Principal Technical Marketing Engineer, and Sean Mall, Senior Solutions Engineer. As we go through the presentation today, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or as a recording, or you just have questions on a particular upcoming webinar topic that you'd like our panelists to address, just go to bigswitch.com/webinars and submit the question using the link provided. We've provided you with handouts today as well. So what you need to do is go to your dashboard, and on your dashboard you can download them from the Handouts tab. We have a full agenda for today's webinar, so it gives me pleasure to turn it over to JP to get us started. JP?
Yeah, thank you, Sharon. Hello, everyone. Most of you have played with SDN technology. You want to deploy SDN Fabric to take advantage of operational simplification, automated provisioning, and fabric-wide telemetry. Now, question is, what should be the next step that helps you move your production application to SDN-based paths? In today's webinar, we will focus on migration of application to SDN Cloud Fabric in Brownfield Data Center. In first section, we will look at how simple and easy it is to migrate to Big Cloud Fabric. Subsequently, we will talk about steps involved in the migration, starting with preparing Big Cloud Fabric, then migrating applications, and finally migrating layer 4 to 7 services and storage. In the end, we will see a small demo highlighting simplicity of the migration. Let's look into simplifying migration complexity with SDN. There are multiple things that needs to be considered before migration. The slide shows a quick comparison if a migration has to happen to a traditional fabric versus to a SDN-based fabric. To provision hardware in traditional network, one has to go through time-consuming box-by-box bring-up. Whereas in Big Cloud Fabric, we support plug-and-play onboarding of physical switches, also known as zero-touch fabric. In traditional network, all the switches are up. You need to look in complex box-by-box protocol for layer 2 and layer 3, making sure that protocols are configured correctly and are converging correctly. No layer 2 loops or incorrect layer 3 route propagation. None of this complexity is required within Big Cloud Fabric topology. Big Cloud Fabric controller builds loop-free topology as a part of zero-touch fabric without any protocol or encapsulation. On traditional network, tenants or applications configure is equally challenging and time-consuming box-by-box activity. Whereas Big Cloud Fabric, with controller providing centralized configuration, makes it simple and easy. That essentially makes application deployment faster. Finally, on traditional network, whole sets of protocols make the migration really complex, especially one has to configure it box by box. On Big Cloud Fabric, we have implemented simple one-click configuration for these must-have features. All these enhancements make migration to Big Cloud Fabric very fast and easy. Modern data centers are architected based on core and pod design. Pods are like atomic unit that connects to core. Pods could be purpose-built for an application or for a specific use case, such as private cloud or big data analytics. These pods could connect to legacy network through core. Here, as shown, the left two blocks are running legacy network with layer 2, layer 3 boundary on aggregation switches. The right two blocks are running SDN-based Big Cloud Fabric solutions with distributed layer 3 gateway in the fabric. As and when new capacity is required in this data center, more and more such pods can be added, providing a systematic and modular approach to expand a data center. Now let's zoom in a single Big Cloud Fabric pod. Big Cloud Fabric is open networking SDN data center fabric that brings hyperscale data center design principles to cloud environments, making it ideal for current and next generation data centers. Applications can now take advantage of high east-west bisectional bandwidth, secure multi-tenancy, and workload elasticity natively provided by Big Cloud Fabric. Customers benefit from unprecedented application agility due to automation, massive operational simplification due to SDN, and dramatic cost reduction due to hardware-software disaggregation. This clause-based SDN fabric has three key components. First, Big Cloud Fabric Controller Cluster. Second, lightweight switch-lite operating systems running on open networking leaf and spine switch hardware. Third, high-performance switch-lite virtual software for KVM-based open virtual switch. Big Cloud Fabric is available in two editions: P-Fabric, where Big Cloud Fabric Controller controls leaf and spine physical switches; P+V Fabric, where Big Cloud Fabric Controller controls leaf and spine switches as well as virtual switches. Big Cloud Fabric supports both physical and virtual workloads and a choice of orchestration software. It provides layer 2 switching, layer 3 routing, and layer 4 to 7 service insertion and chaining while ensuring high bisectional bandwidth. The scale fabric is fully resilient with no single point of failure, and it supports headless mode operation for both the controller failure use case. Let's look into use cases of Big Cloud Fabric. Big Cloud Fabric supports three key use cases. First, Big Cloud Fabric P+V is targeted for OpenStack use case. In this case, the Big Cloud Fabric Controller manages physical and virtual switches. Here, the solution provides most resiliency and best visibility for end customer. Second use case is with VMware vSphere and NSX on Big Cloud P-Fabric. In this case, Big Cloud Fabric Controller manages only physical switches. Virtual switches are managed by vCenter. This solution provides higher level of automation, that is, optimizing operational workflow and best visibility for end customers. If your use case does not fall in OpenStack or VMware category, then you can take advantage of third use case, that is Data Center Fabric. Here, once again, we have P-Fabric, where Big Cloud Fabric Controller manages only physical switches. You can deploy Hyper-V, Big Data, VDI, or storage. This solution provides all the advantages of SDN Fabric along with simplicity and visibility in the fabric. To set the stage, let's quickly compare Big Cloud Fabric with traditional network. Big Cloud Fabric provides zero-touch fabric functionality, where switches, when booted up, will auto-detect controller, download write image and configuration. You don't need to do box-by-box provisioning, which is very time-consuming. Additionally, when these switches are booted up, they leverage LLDP protocol to provide all necessary link information to controller. Using this information, controller builds fabric topology. Hence, Big Cloud Fabric does not require any fabric protocol, simplifying overall solution. Big Cloud Fabric Controller is single pane of glass for all tenant configuration and management. No time-consuming box-by-box tenant configuration, resulting in saving a lot of your time. Big Cloud Fabric provides distributed layer 3 gateway functionality, which enables you to perform layer 3 at top of the rack and also take advantage of full bisectional bandwidth. you are no more constrained by traditional layer 2, layer 3 boundary and choke points. Troubleshooting on Big Cloud Fabric is fabric-wide. Big Cloud Fabric provides tools such as test path and fabric analytics, further enhancing user experience. Controller coordinated upgrade of entire fabric takes approximately 15 minutes, making Big Cloud Fabric solution even more appealing. No box by box babysitting for upgrades, which typically consumes a lot of time. With this, let's bring back our attention to migration. We start with preparing Big Cloud Fabric for migration. On this slide, I'm showing traditional network running application. This application could be using layer 4 to 7 services and IP storage. The plan is to showcase the application migration workflow from traditional network to Big Cloud Fabric. Let's start with deploying Big Cloud Fabric. Big Cloud Fabric controller comes with pre-installed software. All you need is to power on and provide some information such as host name, IP address, etc. Big Cloud Fabric controller has the supported switch software repository. As soon as you plug in any physical switch, taking advantage of Zero Touch Fabric, switches will auto-detect controller and download RAID image and configuration. Entire fabric can be installed in less than 15 minutes. Once Fabric is up and running, you can configure all the basic management protocols such as syslog, NTP, AAA based on your organization requirements. Big Cloud Fabric controller is single pane of glass for entire fabric. Couple of clicks on GUI and you are all set in just few minutes. Now connect pair of cables from Big Cloud Fabric Service Rack Leaf to Core. Enable layer 3 on both ends. This will be your external link. Once again, couple of clicks on Big Cloud Fabric and few commands on Core router, you will get going in few minutes. Fourth step is to enable BGP between Core routers and Big Cloud Fabric. Import all necessary required routes so that your application, when migrated, can connect to external world. This is equally simple as layer 3 configuration. Couple of minutes and you are done. Connect a direct link between traditional aggregation and Big Cloud Fabric. Configure these links as lag. These lags will be used later on for application migration. If a traditional network and Big Cloud Fabric are physically far, such that direct link cannot be used, then you can connect them over VXLAN. These link configuration can be done in minutes.
Just to add a point here, JP, regarding layer 2 link and layer 3 link, as I said, this is typically needs a lag or multi-chassis Ether channel or MLAG for link level redundancy or switch level redundancy. Main thing I want to highlight here is from the BCF perspective, it's a very easy and a cleaner approach we provide to configure link aggregation or MLAG. We call it interface groups. In traditional switch implementation, it takes good number of lines of config to enable this, and also there is additional internal protocols needed to sync up. And on BCF, it's just a couple of clicks to configure this MLAG equivalent functionality, and which I plan to demonstrate as part of the demo as well. Just wanted to highlight that fact.
Awesome, awesome. Thanks. We'll get more color in your demo.
Absolutely.
Yes. So Big Cloud Fabric is now ready for migration. So quick recap on preparing Big Cloud Fabric. As seen from this table, it's very simple and easy to get the setup ready for migration. Enhancements we have brought in using SDN concepts help simplify some of the time-consuming box-by-box bring-up and configuration. It takes max an hour or two to install and prepare Big Cloud Fabric for migration. With Big Cloud Fabric setup ready, let me hand over to Sean, who will walk us through application migration steps.
Thanks, JP. Now we are going to talk about moving an actual application into BCF. So for VMs, this process is pretty painless, and we can take advantage of the nature of virtual machines to move them off of a host. For bare metal, there was a potentially bigger window for downtime than in a VM environment, but can still be done with minimal downtime depending on if you're moving the actual host to a new BCF fabric, Big Cloud Fabric, or simply replacing your switching infrastructure with Big Cloud Fabric and moving cables to the new Big Cloud Fabric switches in the rack. I want to highlight a few points that, as we'll see, all the configuration being done on BCF is extremely simple, easy, and does not take much time at all. The controller takes care of configuring all the necessary switches, which is how we're able to complete a migration in under 1 hour. In these next few slides, I'll show you how VM workloads can be moved to BCF, and we'll come back to the bare metal portion of this at the end of this section. Next, please. Now that you have BCF connected to your core network, moving applications in a VMware environment can be very easy and it can be done very quickly. The first step is to enable vCenter integration on BCF and connect your existing vCenter environment. This only takes a few seconds to basically populate the username and password information for vCenter on the BCF controller. Once BCF is connected to vCenter, Big Cloud Fabric will automatically get necessary VLAN information associated to port groups configured in vCenter. Then Big Cloud Fabric will automatically create and provision all the Layer 2 segments. Using Big Cloud Fabric integration with vCenter, you are able to create hundreds of VLANs in BCF in seconds. This is a very simple and error-proof workflow. Next, please. Adding an ESXi server to BCF generally happens in one of two ways. Either adding new compute hosts and leaving your existing host as is, or physically moving existing hosts to Big Cloud Fabric. Here, we will connect new ESXi server on the Big Cloud Fabric and will be associated on vCenter. Now, these new ESXi hosts are ready to receive any VMs, and as soon as we associate these new servers, the ESXi host will start sending CDP or LDP information. Big Cloud Fabric will see those CDP and LDP information and other information from vCenter to correlate and build the lag groups for the servers. There's no manual configuration, there's no fat fingering of ports or cabling errors, and the auto detection happens in seconds. Next, please. Logically, an application will look something like depicted on the right in a traditional design. In traditional networking and deployment, an application, each host needs to be identified where the app will sit, and then each network connected to that host needs to have the proper Layer 2 and Layer 3 configuration for the application. Then the admin needs to log into every switch and provision those Layer 2, Layer 3 segments. With Big Cloud Fabric, we know this information and we can automatically provision the network without any user intervention. The key here is so far we've only spent a few seconds and clicked a few buttons on the GUI, and we've got a fabric that knows what networks need to be created and where they need to go. Next slide. In the previous slides, we connected directly or using VXLAN to the existing access switches, and then provision the appropriate links to act as port group or VXLAN tunnel with the VTEP on each side. Now we are looking at the logical steps needed after physical network is ready. For this, we're extending VLANs over directly connected Layer 2 port groups or via Layer 3 using VXLAN VNIs. This allows us to move applications one by one without reconfiguring any part of the application. Next, please. If any of your applications require multicast or QoS, those should be configured before migrating applications into Big Cloud Fabric. For example, vSAN requires multicast to be enabled. And in the case of Big Cloud Fabric, it is literally a single click of the mouse to turn on multicast for an entire tenant or VRF. The days of touching all your switches, turning on snooping, and querying is over.
So now I hope you understand how simple our fabric can be and how software-defined networking is not a bad word when you look at our solution. We give you everything you need out of the box and, of course, the ability to customize where you want to. Next, please. Now that the fabric is ready to host applications, you can move the SVI, or Layer 3 Gateway, over to Big Cloud Fabric. Then redistribute these networks into BGP so that your existing core now knows about these networks through Big Cloud Fabric. Or you can move the applications over first and leave the Layer 3 gateways for last. Here, in this example, we're moving the Layer 3 gateway first. Then apply the Layer 3 policies and DHCP relay as required. We support distributed Layer 3 gateway functionality in the fabric, so all the switches share consistent subnet gateway IP and MAC information. The Big Cloud Fabric controller provides a single pane of glass for configuring Layer 3 parameters, and there's no box-by-box configuration, which is why the process is simple and easy, and why it can be done in minutes. Next.
Here, just to add a point here, Sean, regarding moving Layer 3 gateway to BCF.
Sure.
In traditional network, if you have to move the Layer 3 gateway, essentially you need to configure IP to a VLAN. Essentially, you have to do it on 2 aggregation switches. Then you have to run HSRP or VRRP or any kind of FHRP protocol to get a gateway IP, essentially to get a virtual IP to all the hosts. So in Big Cloud Fabric perspective, as you mentioned, it's a distributed gateway. You just need to give one IP address on a BCF controller for that particular segment. We provide the gateway for all the hosts connected to the Big Cloud Fabric on that segment. So that's, again, I want to just compare and contrast with the traditional network and this. And I mean, so that way it helps you to bring clarity on what we do, how we do, and what value we bring in to migration, as well as deploying any application on Big Cloud Fabric.
Yeah, thanks, Ganapathy. That's a great point. So now once the gateway is configured, only Layer 2 functionality is left on the traditional network for that application. And after the L3 gateway is moved, your current application can reside in the existing network as is, while having Big Cloud Fabric ready to accept the application once a change window is available. This allows you to move a single VM or a whole application at your leisure without being forced to do any sort of hard cutover. Next. Now we're ready to move VMs. It's simple vMotion of the VM onto the ESXi host or hosts that are connected to Big Cloud Fabric. Big Cloud Fabric will see the VMs move and provision the switches in the fabric with the appropriate VLANs automatically. You don't need to spend time figuring out where destination ESXi host is connected in Big Cloud Fabric, and you don't need to worry about extending the required VLANs on the specific switch ports in Big Cloud Fabric. BCF automation kicks in to provision the correct VLANs and access for the correct switch ports. This happens in seconds or less. Next. Depending on your situation of standing up new compute, the process of migrating the application can be done in minutes with vMotion. For reusing of compute, it may take a little longer as you leapfrog hosts between the old and the new racks, but the leapfrogging will definitely take longer than actually moving the application in vMotion. Next. This summary slide shows the amount of effort needed to move into Big Cloud Fabric. Once the physical hosts are up, it's less than an hour. Besides the physical components, the only manual tasks were turning on multicast or QoS and tagging VLANs to your existing network. The rest is completely automated. Coming back to the bare metal conversation for a minute, the process is similar with the caveat of having to either shut down and move the bare metal server, or ideally, you would have a Big Cloud Fabric switch sitting on top of your existing top rack switch, and you can quickly swap cables over to the Big Cloud Fabric switch. The latter option will provide negligible downtime, especially considering there is no spanning tree or convergence that needs to take place on the Big Cloud Fabric when we're connecting the bare metal server to the fabric. That's all I had to talk about, so I'll turn it back over to you, JP.
Thanks, Sean. So now let's look into the approach one can take for moving layer 4 to 7 services and storage. As we have seen earlier, virtual machine moving is easy. Similarly, if you have virtual services such as virtual load balancer or virtual firewall, you can simply vMotion it to Big Cloud Fabric. If you have physical servers, depending on the location of the service appliance, you can just move the cable to the Big Cloud Fabric or power down redundant service appliance first, move it to Big Cloud Fabric, and then move the other appliance in the HA cluster. Especially if you have virtual services over vSphere, all you need to do is vMotion in the vCenter. Big Cloud Fabric integration will auto-configure all the necessary switches for respective VLANs. For physical service, Big Cloud Fabric supports service insertion using policy-based routing concept. When we move layer 3 gateway in earlier section, those policies were configured on the Big Cloud Fabric. So no new configuration is required other than physically moving this service device. For whatever reason, if you happen to change any policy, it's a couple of clicks on Big Cloud Fabric controller GUI. Couple of minutes and you are done. Once done with service migration, let's clean all the configuration from traditional network and from direct links between two fabric as a good hygiene. Now the objective is to move storage from traditional network to Big Cloud Fabric. Storage segment is already pre-configured by vCenter integration with Big Cloud Fabric. Now is the time to enable additional functionality such as QoS or PFC required by your storage device. On Big Cloud Fabric controller, with a single click, you can enable these features. No box-by-box time-consuming configuration required. Again, it's simple and fast. Once the feature configuration is done, it's time to move storage. Based on type of storage you have, your exact steps will differ. Here, I am using redundant cluster storage which operates in N+1 redundancy mode. Physically move one storage array and connect it to Big Cloud Fabric. Enable segment membership for this storage in same storage segment. Once it's connected to the segment, data rebuilding will bring the storage in parity. Again, depending on physical location and nature of the move, it could be just a cable move from traditional switch to adjacent rack Big Cloud Fabric leaf switch. Repeat for rest of the storage array and you are done. Clean up any configuration left on the traditional network as well as on the Big Cloud Fabric direct link or VXLAN link. Now you are ready for next application migration. As we can see from the summary slide, it's fairly easy to configure features on Big Cloud Fabric and move services to Big Cloud Fabric. It takes less than an hour to complete some of these migrations. Of course, actual time will depend on how big of your storage clusters you are moving, but the fact is you don't spend time on a box-by-box configuration, you spend time on actual application move. Let's see some of this in action with demo presented by Ganpati.
Sure, JP. Thanks a lot. Goal for me is to go over the workflow which Sean and JP presented earlier. I'll be taking some of these slides shown as part of the demo so that you can relate those slides to what I'm doing so that you can experience a typical workflow you would see to deploy or especially the migration use case we are showing today. The first part of the demo would be like preparing the Big Cloud Fabric, just like the presentation we had. And then the second part we would show really how you can migrate the application to the Big Cloud Fabric in a vCenter environment. The first thing first, we have already deployed Big Cloud Fabric using Zero Touch Fabric, which takes a few minutes to set it up. It could be 3 racks, 10 racks, 16 racks, or 32 racks, it takes just 10 to 15 minutes to bring that up. Then second step, once you have the BigCloud Fabric up and running, we'll configure a system management configuration, which I'm going to demonstrate. So this is the BigCloud Fabric controller. This is a single pane of glass. Again, there is no configuration now. This is the fabric view with the 3-rack topology. These are the leaf switches, which are interconnected with the 2 spine switches. You can have up to 6 spine if need be. Then for all the system management stuff, you go to the settings tab and configure it. We'll start with the setting of the clock. If you want to add more NTP servers to the configuration, you can have it. Again, all this configuration is done on the BigCloud Fabric controller. You do not have to do box by box, even though you have 30, 40 switches managed by this particular BigCloud Fabric controller. And next would be the SNMP configuration, which is typical in any network. Enable the SNMP community, SNMP traps, and also provide the SNMP server so that a trap can be sent to that server. Then also configure the thresholds, thermal sensors, and all those event thresholds which you want to set it up for your fabric. And the third configuration would be it is AAA authentication, authorization, accounting configuration using TechAxe or Radius. We support both. It's few clicks, you are ready to set this up on BigCloud Fabric. Again, it's a single pane, only on one device, controller, active controller you need to do. Everything else is taken care under the hood by the controller. And again, the S-Flow is the other one where you can send the samples, packet samples coming onto your fabric to the S-Flow collector. Again, it's very simple. Click a few clicks to configure the S-Flow collector address. That's it. You're ready to go. One configuration for entire fabric. Finally, syslogging. Again, you can give a syslog server address here. Multiple syslog servers are supported. You can make both switch and controller to send the syslogs to the syslog server. Then finally, I will walk you through the QoS, which we talked in the slide. Essentially, if you have a multicast application, one of them could be the vSAN storage or a few other applications you can see in the financial environment. The enabling QoS is very simple. A couple of clicks to enable the PFC, the I2C related, the TLVs for your entire fabric. Again, I always feel nice when I have to compare it with the traditional network because in past life I have done this. You have to configure tens of lines of configuration just to enable the lossless fabric. That is a priority flow control QoS on traditional switches. In our case, it's just 2 clicks, enables entire configuration on entire fabric. That's the beauty of our BigCloud Fabric implementation. So now, once we have system management configured, now connecting the BigCloud Fabric at L3 and configuring BGP. Now go to the interface group. This is where I was referring earlier when JP was presenting. How do you configure multi-chassis Ether channel? We call it interface group. Essentially, give the name like core router, link aggregation. Pick the rack you want to have that. Just pick the port. That's it. You have now multi-chassis Ether channel equivalent, which is we call interface group. On BigCloud Fabric. Then now let's create a tenant to create a BGP configuration. Let's call it a vCenter tenant. Again, one more point here, the multicast, like Sean earlier mentioned that multicast is just a click. That's where you click that button from red to green to enable the multicast for the entire fabric. And you're ready to go. Again, this is both layer 2 and layer 3 multicast. Excuse me. A layer 3 multicast, you don't need any additional configuration to enable the multicast for your application or fabric. Now create a segment to layer 3 to core and give a subnet IP, segment IP. Then create a BGP configuration, router ID, AS number, the speaker IP. Then also configure redistribution so that whenever you configure segment subnet, it will be redistributed to the core so that you can get a traffic from the core to your application, which is hosted on BigCloud Fabric. Now, graceful restart, again, everyone knows about BGP. This is for HA. We enable that as well. Then create a neighbor to the core. Now it's an idle state. Now it's established. More neighbor details are on the screen with a click. And this is the route we received from the core so that we can send the traffic out to the core and beyond to internet. As soon as you enable the BGP, you get those routes. Now the big cloud fabric is configured with the layer 3 BGP capability. Now the fifth step here is that configuring the direct L2 link for migration, layer 2 link to the aggregation switch. Again, this is a multi-chassis Ether channel equivalent. We call it interface group. Couple of clicks, done. So you have the configuration without having to go through the few lines of configuration. So that's about the preparing big cloud fabric for migration. That's the first part of the presentation we showed. The second part is really migrating your application and your layer 4 to 7 services to the big cloud fabric. Okay, so this is vCenter web interface. I have 4 compute hosts, essentially the first 2 hosts. As Sean alluded earlier, there are different approaches to do the VM migration. Either you do it physically, move the ESX host first, then you do a vMotion, or you directly connect the ESX host cables to the BCF switches directly without having to be doing a VM move. There will be a little disruption in traffic with this approach, where we are going with the phase 1 and phase 2 approach here. The first 2 ESX hosts are the phase 2 ESX hosts. Essentially, we will be moving it later, given we have the VMs hosted on those. And whereas the next 2 ESX switches, which doesn't have any VMs currently, we will move this first to the big cloud fabric. Then once we have this ESX host on the big cloud fabric, then we'll do a vMotion through that layer 2 link, and then we'll move the first 2 ESX hosts to the big cloud fabric to complete the migration. So this is the vCenter networking topology. Essentially, I have multiple port groups for this particular migration. I have 3-tier app, web, and a DB with the VLAN 11 and 12 and 13 as shown in the screen. Then I also have a few other port groups on the vCenter, like vMotion, IP storage, and all those port groups. Now, from the networking perspective, from our side, we need to enable the vCenter integration. Before that, let me show you how it is shown on the traditional network, one of the aggregation switch. I'm accessing it here. Just to show that these VMs, I have 10 VMs in this particular topology. It is hosted on the traditional network. This is output from aggregation switch. Again, if you want to debug, you have to go to every switch in this traditional network and debug it, how it is configured, where this particular host is, and all those things. And this is the gateway configuration I have on the traditional network. Then we'll be moving this to the big cloud fabric in the next part of the demo. But I just wanted to highlight those IP addresses for now. So with that, now let's enable the vCenter integration. That just takes a few seconds, as Sean mentioned earlier. I go to the integration tab, click on the vCenter, then the name, give just a name, whatever name you would like to have here. Then give the IP address of the vCenter and the credential associated with that vCenter. Then pick the tenant which we configured earlier for the BGP so that we can deploy all our application on this particular tenant. Then just save the configuration. That's it. Once you configure it, it just connects to the vCenter. Now everything is kind of automated. Like we provide all the fabric automation and the visibility for all the vCenter networking right from the big cloud fabric controller. What it means is when you click on the tenant now, as you can see, earlier we configured only one segment just for the layer 3 connectivity. Now you see other 8. The segment got created, which is nothing but the vCenter port groups we have on the vCenter. This got dynamically created right just using the 4 lines of configuration or a few clicks of configuration on the BCF controller. You do not need to do any manual configuration at all. Just to go back to the vCenter, as you see, we have all those 8 port groups and associated VLANs on the vCenter networking. And just to mention that the segment name comes from the tenant name hyphen VLAN number associated with the port group. So in this case, vCenter 11, vCenter 12, and 13 are the three the application segments we are focusing. Now, so this is more of a graphical representation on the VCF controller. Now, if you want to go a tabular representation of this configuration, again, there are multiple segments here. If you look at the third column from the left, the description column says that port group name, which is the name you have given it in the vCenter configuration. But from the segment name perspective, as I said, it's a tenant name dash the VLAN number associated with that particular port group. Now, at this point, now we enabled the vCenter integration. However, we did not move any application yet. Now, and however, the BigCloud Fabric is already provisioned with all the segments VLANs required for the application migration, without really having to do any manual configuration other than the integration configuration, which is a 4-line configuration on CLI or a few clicks on the GUI. Now I'm physically moving those two phase 1 ESX hosts I mentioned earlier, 33 and 35, to the BigCloud Fabric. Then we'll see how we auto-detect these hosts right here. As you see, this we just connected the cable. It could be just moving the cable from one switch to the other switch on your same rack. We just auto-detect this particular ESX host and form a link aggregation. Again, it could be regular link aggregation, or it could be MLAG equivalent. We provide that dynamically using LLDP, as you can see. And exactly, if you want to expand and see where it is connected, exactly it gives the port numbers used where it is connected on the physical switches. That's how we dynamically learn. If you move it, we'll relearn it and program the fabric accordingly. Again, everything is dynamically done. You don't have any manual configuration. So now this is the application. Again, now let's extend the VLANs on that layer 2 direct link so that we can do a vMotion. The way you do it is you go to the tenant and access the VLAN you want to extend. Now in this case, the web segment, just pick the layer 2 link to the lag and give the VLAN number there. That's it. Then give the same configuration for other segment as well, so that you can extend all other VLANs corresponding to the application you are trying to migrate, including the vMotion for the storage. vMotion for migrating the which will be used for migration, and also the storage port group or storage segment for iSCSI or NFS you may have. Also extend that so that migrated VMs can access the storage right from BigCloud Fabric to the traditional network. So now looking at the endpoints, as you see, all the VMs are learned here. However, on the rightmost column, we have VLAN. After that, we have interface group where it is connected. Currently, all the VMs are still on traditional network. That's why it is showing that pointing towards the layer 2 link to ACK, to indicate that it's still on the traditional network. Then we'll come back again after the application move and show the updated information on this screen. So we have now layer 2 connectivity and the layer 3 connectivity configured. Now it's time for a real application move from the vCenter. We'll use vCenter. Just before that, let's move the gateway IP from the traditional network to the BigCloud Fabric. You can do before the move or after the move, just like Sean mentioned. But in this case, I'll be moving it before the application move. I'll move the gateway IP from the traditional network to the BigCloud Fabric, and the traditional network would act like L2 only. So just by deleting the IP address. So at this point, you may see some, a traffic interruption to the application. However, it will be a very minimal, and you just come to BigCloud Fabric and reconfigure those IP addresses as a gateway IP address. As I told earlier, we do not need HSRP or VRRP or any other kind of protocol. We just give this IP address on one of the active controller. We'll take care of doing the distributed gateway across all the leaves. Every leaf in our fabric is a router, so that way you get all the distributed routing and gateway functionality right on top of rack. You do not have to go to the aggregation switch, just like even JP mentioned earlier in his talk track. So now let's start with the vMotion and do all the vMotion from traditional network to the, so essentially what we are doing is moving VMs from the first two hosts to the next two hosts, which are now part of BigCloud Fabric. Just you can use manual way, which is not practical in your deployment, but you can use the vCenter automation to migrate your these VMs to the ESX host, which is connected to the BigCloud Fabric. As I'm trying to move the web VMs here, we on BigCloud Fabric perspective, we update the segment membership, as Sean mentioned, dynamically again. So we do not enable it on all the ports. Based on where VMs are, we enable the segment membership. Then, as you can see, segment membership got updated with the new interface group added to that particular segment. This is again dynamically, as VCF controller gets notified by the vCenter about that VM residing in this particular ESX host. We just enable that segment membership. Okay, now let's migrate other VMs, app and DB real quick. Again, now in the background, vCenter notifies BigCloud Fabric, and we'll provision all the segment membership for all the app and DB tier on all the ESX hosts wherever it is applicable. That's it. We also have load balancer services here. We are moving that as well as part of this migration. If it is a physical appliance, then it's move one at a time. The services HA will take care of providing the uninterrupted service for you from the load balancer, firewall, or the storage services perspective. Now, again, coming to the endpoint page on BigCloud Fabric, as you can see now that interface group column on the right got updated with interface group associated with the ESX server connected to the BigCloud Fabric. Earlier it was showing layer 2 link to the traditional network. Now, because all the apps are moved to the BigCloud Fabric, this got updated as well. So from now, just to end this migration, close on this migration, essentially you move those two ESX hosts to the BigCloud Fabric, the initial two ones which had VMs initially. Now we are moving those other two ESX hosts here. As soon as you connect the cables, we detect it again just like the other two ESX hosts through the LLDP mechanism. You don't have to do any manual configuration. Think about your environment. If you have hundreds of ESX server, it's just moving the cable. You don't have to do anything on the BigCloud Fabric. That's how simpler the migration to BigCloud Fabric is. From not only from the layer 2 configuration aspect, it's also the all the segment membership and other aspect of the migration to BCF as well, and also provide a visibility on top of it. We are not focusing that today. That's what I had, just so that you can experience application migration workflow to BigCloud Fabric and how you can migrate your application in a simpler way and also in a rapid application migration you can do. With that, I will hand it over to JP again.
Thank you, Ganpati. This was awesome. So as we have seen in this webinar, it's fairly easy and simple to migrate from traditional network to BigCloud Fabric. It takes very less time due to all the enhancements we have built in the fabric. Of course, not all migrations are same, but with little planning and leveraging SDN concepts, one can have much smoother application migration that can be finished in less than a day. So with that said, Sharon, back to you. Are there any questions that we have time? Let's
We definitely have some questions. We have a question: which southbound protocol does the controller use, standard-based or proprietary?
So we use standard-based protocol between controller and the switches. It's OpenFlow.
Great. The next question is, does the fabric support micro-segmentation?
Micro-segmentation is very specific to NSX. However, we can provide similar functionality in Big Cloud Fabric as well. So I would not say it is exactly same, but it's very similar functionality that we can do in Big Cloud Fabric.
And also we complement NSX micro-segmentation by being the physical fabric for NSX deployment. We just complement the NSX technology there.
So that's a very good point. NSX being a SDN overlay, we become an ideal SDN underlay for NSX deployments.
Great. That's the only questions we've been, Sean's been great in helping me answer the rest of the technical questions. So back to you guys. Do you have any final thoughts?
We are good. I mean, we covered most of the stuff. We are good from here.
We might want to talk about the online labs that we have available as well to test drive our solution. If you go to labs.bigswitch.com, users can go in and register. It's free, and they get their own sandbox to be able to log in and play with our solutions.
Perfect, Sean. Thanks for doing that. I really appreciate it. So as Sean said, definitely if anything here piqued your interest, you're welcome to go to our website and leave us a question or send us an email at info@bigswitch.com. And as Sean said, we do make it easy for you to get started with Big Switch Solutions. There are a number of resources, including BSN Labs, and we've also given you a handout for BSN Labs, as well as for Big Cloud Fabric, which is what we talked about today. All of our past webinars, including this one, are posted online. We have a catalog of those. You just have to go to our website and click one of the green buttons on the home page. We also want to suggest that you mark your calendars for our next webinar, which will be Wednesday, November 16th at 10 a.m. Accelerating multi-container network automation using SDN Fabric. Watch your email for registration details or visit our website at bigswitch.com/webinars. Well, that concludes our presentation for today, but if something we talked about piqued your interest, just head on over to our website, bigswitch.com, or send us an email at info@bigswitch.com. Thank you and have a great rest of your day.